I think the more people think about blockchain technology, the more they realize that blockchains are really useful for managing assets, right? So we can store things like virtual currencies, ERC20 tokens, ERC721 tokens, and over the next 5 to 10 years, we're going to see an increasing range of assets that are managed by these blockchain-based systems. And we can transfer those assets using little small computer programs known as smart contracts. And that's pretty powerful, but that's not going to be enough. In order to really take this to the next level, we're seeing the emergence both in the Ethereum ecosystem and in other ecosystems of actually building a legal layer on top of it. And what that legal layer will do is wrap these assets in legally binding contracts so that we can engage in real-life commerce. And it's that symbiotic relationship between asset management and the legal system that has really built Western society. So Wall Street is really a symbiotic relationship between lawyers and bankers. The insurance industry is claims and risk managers and lawyers. We're seeing the same thing in media, right, where we have managing the property rights of creative workers and lawyers structuring transactions. And we haven't yet built that in the blockchain-based ecosystem, and open law is really a first attempt at it. And what this is really a neutral agreement layer for blockchain-based ecosystems. So we can create legally enforceable agreements that can execute smart contracts. And what we're going to show you is by creating this protocol, many of the dreams and the aspirations of a number of blockchain-based projects can quickly come into fruition. We can actually rapidly build and prototype entire end-to-end solutions. And we're going to show you an end-to-end solution for a real estate transaction, a hypothetical one in Australia, where you can actually buy, using a standard contract, land in Australia and have the payment handled and the asset registry ultimately updated using one of these, using open law and the Ethereum blockchain. And so we're moving beyond kind of the hype phase of blockchain technology into the build phase. And a big reason why we can do that is tools like open law are here and emerging. And what we're doing is bringing software tools that have existed in the software development environments for, at this point, about 10 years into the legal industry. We're creating template-based systems where you can take agreements, you can mark them up using a markup language that we created and regenerate them on the fly. And through this process and through this markup language we've created, you can actually embed logic, the logic that's in my mind as a lawyer and other folks' minds, into the agreements so that you can rapidly create not just one type of agreement, but a whole bunch of different agreements and modify the terms on the fly. And then we can use the power of the Ethereum blockchain and other blockchains to trigger smart contracts to keep track of all these agreements, different versions of the agreements, and the signatures, and actually create programmable workflows. So we can do all that business process and commercial logic using this environment that we've created. And beyond that, particularly for the software developers in the world, we're creating collaborative places. So we can create and bring people together so that they can stop creating the same agreement over and over and over again, and instead work together to build common templates and modify them and fork them and improve upon them so that lawyers stop acting like shoemakers back in the 1700s working in their own shop and start acting like responsible folks that are working together to actually deliver high quality legal services. And so there's a couple different pieces of the open law protocol that we're building. The first thing, and this is the base layer, is the Ethereum blockchain, where we store on the blockchain the legal references to the legal agreements, where they can be accessed, tracked, and managed. We've created this really robust domain-specific markup language that is easy enough for lawyers to use so they can actually embed in that agreement common things like variables or optional provisions and kind of trace that all through. We've created this secure execution environment, which we call the open law virtual machine, which enables one or more smart contracts to actually be executed once the relevant parties have signed the agreement, even on public blockchains. So we've actually solved some of the privacy issues with regard to commercial contracting on public blockchains. We can create a secure private environment and actually execute these agreements. And all of this is going to be surfaceable in common APIs that anybody can use. So this is really a baseline protocol that you can embed into any type of an agreement, any type of environment that you want. And the key piece of this is this virtual machine. We built effectively a state channel here where we create a secure, formally verified execution environment where you can create an agreement. That agreement can be signed by both parties. Execution can occur within this environment, and you can mutate the state over time. So you can feed in inputs or other actions to change that agreement over the course of its life cycle. And all of it is secured via the Ethereum ecosystem. And this is really horizontal blockchain-based infrastructure. So this is not a domain-specific piece of technology. It's actually something that will impact a range of different industries and businesses. So if you want to actually build smart contract-based applications, many of these applications are a token, a handful of legal agreements, and open law. And we now have the tools to do it. And I'm going to show you what Jarrell put together literally in a matter of days, which folks have been talking about for literally years.
Thanks, Aaron. So I'm going to pull up this infographic, just kind of give you a preview and an overview of what we're going to walk through. But we partner with leading Australian law firm Core Chambers Westgarth to build an end-to-end real estate transaction. So we'll start off with using the editor tools of Open Law Core to create and execute a legally binding sale of land contract that governs the transfer of property in Australia. Now, with Open Law's blockchain-enabled solution, we're able to have that legally binding contract interact seamlessly with a programmable code, what you consider a smart contract on the blockchain, and that smart contract will manage the contractual promises around the sale of the property. So that smart contract is supposed to be a representation of a digital land registry. It's based on the ERC 721 non-fungible token standard. So the concept is each token represents a different piece of property. Parties will be able to interact with that smart contract. Presumably, the government will set up some sort of interface for the parties to be able to make a deposit on the property, for a third party, which would usually be a bank or a lender, to come in and fund the remaining purchase price, for the seller to withdraw the escrow funds and to actually transfer the tokenized property. Let me show you. So this is an example of what an interface could look like. Each piece of property has its own unique string identifier. The party would be able to enter that here into the interface to get details on the property. So here we see the physical address of the property, we see the owner, and we can see the history of the ownership, which is important, especially when you're tracking kind of the title and deeds for properties, to see like who owned what before that. But let's go ahead and dive in and start creating the contract. So we'll go to the actual sale of land contract. So it's a standard sale of land contract. It contains the terms that you would expect to see in this type of transaction: a description of the property. We're going to afford the user the ability to put in the property's address. You can see the purchase price terms. So the parties here, in this case, agree to transfer the property for 10 Ether. The buyer will agree to make a single deposit, which will happen prior to settlement of 4 Ether. And down here, you'll see the financing terms, where a third-party lender will come in and fund the remaining 6 Ether. So I filled in most of the fields. Let me go ahead and fill out the rest. And I just wanted you to be able to see kind of a part of our editor tools. When you fill in these parameters, you'll see the contract on the right-hand side automatically update. So let me go back over and highlight kind of just what I did. So some of the key parameters that are actually going to get sent to the smart contract would be the buyers and sellers' Ethereum addresses. And this is important to facilitate the distribution of the tokenized property in the escrow funds. We have the actual address of the property that's under sale. So you'll notice here that our markup language returns the unique string identifier for this property. This is going to be the same identification used in the presumable digital land registry to track this particular property. So OpenLaw would be synced up with how the digital land registry would be tracking the property. The relevant Ether amounts have been filled in. Those will be also a key parameter that will get sent to the smart contract. So we'll take a look at the source, and this is where a user is able to use our markup language to wrap the logic and conditionals around standard legal prose. Highlight here, so this block of code, starting at line 45, is where we actually allow the user to make the call to the smart contract. So after the parties have signed the smart contract, the key parameters will get sent, and it'll initiate the sale transfer. So with all the fields filled in, we'll go ahead and send the contract out for signature. You can, let me type these addresses in real quick.
Yeah, so what Gerald's going to do right now, as he types in the email addresses, it's going to send out to each party an email where they can click a button and sign it. So imagine if you can sign agreements just by clicking a button instead of actually having to use a pen and paper. But beyond that, and what we're going to show you over the next couple minutes, is a process that usually takes at least a half a day or several hours in order to close these transactions, and literally up to a month in order to update a registry. We can narrow that time down to about 10 minutes. So we can move to commercial activity that used to take days and hours down to things that take minutes. And that's really the power and what we're presented with this technology. The rapid transfer of assets, trusted execution environments means that we can engage in commerce in a much more efficient way. And by engaging in more efficient commerce, we can actually improve society in profound and deep manners. All right.
So we'll go ahead and, in the interest of time, I'll go ahead and fast forward, but basically each user would get a link, an email with a link to access their OpenLaw account to be able to review the contract and sign it. And this is kind of where the blockchain piece comes in. So when a contract gets signed by the parties, a signed version of a cryptographic hash of the contract gets stored in the blockchain, so we get the benefits of the immutable record of the contract there. And through our UI, you can actually see a record of these transactions. And then, so as I mentioned before, after the parties sign the contract, OpenLaw is coded in a way that it automatically makes the call to the smart contract. And again, we can click on this link to see a record of that transaction. So with the use of the OpenLaw agreement to kind of trigger and initiate the sale transfer, we can go ahead and go back to the land registry to see how that's been updated. So we can see that the property is now a pending sale. We can see the buyer's Ethereum address. We see the purchase price, deposit amount, and the loan amount. This last line down here is the escrow balance, and we'll see how this gets updated with the next few steps. So pretty much at this stage, the buyer would come in and just follow the flow of how the contract has been set up. You can go to the interface and make the deposit. We'll make sure we're doing it from the buyer's account. So I'll keep this open here because we'll let this go through the process of being mined independent to the blockchain. But a couple things will change here. We'll get confirmation that the deposit has been made. The escrow balance you should see increase by an amount of 4 Ether, and then we should see the buyer's account balance decrease by that same amount. So we'll give this a couple seconds to run through. This is MetaMask, yeah. Yep. Okay, so there we go. We get the confirmation, we get the increase in the escrow balance, and then we just saw that decrease right there. So the next step in the flow would be a third-party lender would come in. In a real transaction, this essentially would happen immediately prior to settlement. So after all the financing conditions are met and all the other conditions are met, the buyer wants to come in and fund the loan at the last second to make sure the transaction has gone through before depositing their amount. So we'll go ahead and switch to the account that's supposed to represent the bank. And again, I'll keep this open so you can monitor the account balance. This should decrease by 6. We should see the escrow balance increase by 6 to go up to the total purchase price of 10. And we'll get the confirmation here. Okay. And here we see the increase, and then we'll see the decrease. There it goes. All right, so the last step, so now all the escrow funds are in. The seller would come to the interface, withdraw those escrow funds, and finalize the token transfer. So we'll go ahead and switch that account for the seller. Keep this open. So a couple things we'll notice what happens when this transaction is finished. We'll get a confirmation of the new owner. We'll see a record of this transfer be appended to the history, so it should be number 7 that's added. And then we'll see the seller's Ether account balance increase by a total of 10 Ether. And there we go. So that takes us to the end of the transaction. I mean, this is our first iteration of showing how we can use open law on the Ethereum blockchain to manage, automate, and streamline the sale of property. I think we can all agree and recognize that property law is complex. So there are other things involved besides kind of basic deposit, loan, and withdrawal and transfer. So in future iterations, we're considering other options as far as kind of using multi-sig wallets to handle multiple buyers and sellers. We're trying to figure out a way to most efficiently attach the information that's related to a property, things like easements, mortgages, restrictive covenants. And then perhaps the most feasible improvement we can make in the future is setting up our contract template and our smart contract in a manner where it makes the payment of taxes related to a property sale to any relevant government entities. And we would do that in a way where it essentially happens right at settlement when the seller withdraws their funds and transfers the tokenized property. But, so that takes us to the end.
Yeah, I think the last piece, so you may be thinking, oh, this is an Ether, but this is part of a larger project that's occurring. And I think we're going to see over time these fiat bridges emerge where we can actually denominate things in US dollars or here Australian dollars. And this entire process would not need to necessarily be an Ether. And at the same time, you're going to see bridges that are being built to traditional banks, where those traditional banks are linked to Ethereum-based addresses as well. So then it will look no different than if you were logging through a process that would interact with the traditional financial services system. So still, this is early days, but again, we're moving beyond the ideation stage, which I think we've been in for the past year, and now we're in the build stage. And this is like the first glimmers of the types of tools and technology that we can begin to develop. So that's it. I don't know if anybody has any questions. We'd be happy to answer them. Yeah, go for it. So this works. Yeah, this is code. It works, yeah. So, and I think that beyond that, we've solved a number of different problems. So we're not quite sure what Materium is going to be. It's basically a white paper. But beyond that, we've actually solved privacy on a public blockchain. So we create this secure execution environment where parties can actually engage in commerce like we do today. If me and Gerald wanted to enter into an agreement on paper, we could enter into it and store it, both in our local storage, and nobody else would need to know about it. In any digital environment, except for the environment that we've created here, that's not possible. So that's really the power of why this actually will have meaningful consequences when it comes to legal agreements. No, it's peer-to-peer. So any party that's running one of the instantiations of OpenLaw, our layer 2 solution, will be able to basically trigger that and create that execution environment. So that could be multiple parties, or that can be one party that does that. Yeah.
Great presentation.
Thanks.
How like the world is still running on paper-based like land registries, how is like OpenLaw going to kind of that's just going to be redundant for a while and eventually move to digital, or how do you see that interface with the paper-based existing kind of?
It's a great question. Yeah, so the land registry piece is really a government question, but why we chose Australia in part is because they're in the process of exploring how they can digitize their land registry system, and so they're exploring what that would look like in the most advanced technology that's out there. So if you're a government, you're not going to update your land registry every year. You're going to probably do it every 20, 30, 50, 100 years. So if that process is ongoing in a country, they're likely looking at blockchain technology to solve it. And in part, it's because of this trusted environment that can occur, and you don't need a bureaucrat to spend 30 days to put a stamp on something and put it in a filing cabinet. We can now know that if parties are paid, and if it's represented in one of these ERC 721 tokens or something equivalent, we can keep track of who owns what at what point in time.
Eventually this will disrupt title insurance, right?
So that's an interesting question. Yeah, so in Australia, they use a different system called the Torrent system, where they don't have title insurance. In the US, we should talk about that separately. Yeah.
Yeah, this is great. Obviously, as you think about the fiat bridges like you talked about, I mean, one thing would be something like using a DAI so you can denominate transactions in like
Yeah.
fiat. But the other component is actually like triggering a fiat currency transfer. Have you guys found any projects you're able to partner with on that?
Yeah, so we are integrating Stripe into this too. So Yeah, so the nice thing about surfacing it all is APIs. We'll be able to build other API hooks into the system. So if you wanted to trigger payment via Stripe, it would do the same exact thing. So, yeah.
Two-part question. Are either or both of you lawyers? First question.
Yeah, I'm a law professor and lawyer.
I'm a lawyer also. Yeah, it's background in corporate securities law. So.
So then follow-on question. Is this stuff legally binding? So like if I wanted to sue the person I bought or sold the property from and I went to court and I'm showing them cryptographic hashes, what's the judge going to say?
Yeah. So, and Gerald showed this, but there's an agreement that was signed, so that's the whole point. So if there's a dispute, we can go back, pull that agreement from the persistent data storage system that's called a blockchain, and show that to the judge and say this was our deal. You know, let's say I was the seller here. I felt like Jarrell did something wrong, violated a closing condition. We can unwrap that entire transaction, and we have all the evidence of everything that's occurred. We have the agreement. Maybe we had drafts of agreements. We can actually show that as well. And we can show that we signed it. We can show that all the payments occurred, and that title was inappropriately transferred.
So is that signed law, like the same electronic signatures, like DocuSign?
Yeah, so there's, in the US, we're in good shape. We've solved all these problems. Other countries, particularly civil law countries in the EU, they may have harder times with this, but we're good to go in the US. Yeah?
One of the things that, and I'm not a technical person, as you know, but one of the things that's always challenging in looking at the smart contract stuff and understanding it in relation to both property and other kinds of property, intellectual property, it seems like it addresses the actual monetary transaction factors in a contract. But a lot of contracts have a lot of fuzzy promises and things that aren't necessarily quantifiable in code, I would expect, you know, whether they're reps and warranties or whether, whatever. How does that get translated, other than the actual transaction itself, into a smart contract?
Yeah, so that's, again, why we built this system. So we think some parts of agreements will be easily translatable into code-based systems. So asset transfer is probably the most logical one. I think over time, we're going to see the development of libraries that can move even some of the mushier parts of agreements into code-based transactions or code-based provisions. But for now, really the core innovation of a blockchain is not transferring all parts of agreements into software. It's really asset transfer. It's rapid asset transfer. And that's exceptionally valuable in almost every single domain. If that's IP and you need to transfer rights to property, we can do that in a fairly atomic way and clear way. If it's real property, we can do that. If it's virtual property like Bitcoin, we can do that as well.
Rights with conditions attached to it. Is that now?
Yeah, so that's what's interesting. So the ERC 721 token standard, there's a new token standard that's being proposed. I think it's 993 or 998. Yeah, so you can delegate rights from property. So you can actually model out in the IP context, for example, each one of the, like a right of reproduction, right of distribution, public performance, et cetera. And here we can delegate and say that the 721 token has a right of easement, and then that can be transferred separately. So you can actually keep track of even the rights at a very granular level.
So I think we're out of time, but we're just right around the corner and happy to answer more questions outside. So thanks everyone.